So many times in chemistry, or in science particularly, we need to convert from one unit to another. So this video, I'm going to show you what I believe is the most effective way from converting from one unit to the next. This method, it's called dimensional analysis. All right. Oftentimes, it's called factor label method. This method consists of converting a quantity in one unit into an equivalent quantity in a completely different unit by using the conversion factor. All right. And so basically, it's like you have your starting quantity. All right. And then you will multiply by some conversion factor. Okay. And when you do that, then you will have the equivalent quantity in the unit that you wanted. Okay. Now let's kind of talk about conversion factors quickly. Like, what do I mean by this? All right. Well, in conversion factors, okay, are derived from what we call an equivalent statement. Now, an equivalent statement is just basically it describes how two units are equal to one another. So, for example, we know that for every 1 meter is equal to 100 centimeters. This is an equivalent, all right? This is an equivalent statement, okay? Or another example is that we know that there are 12 inches for every 1 foot, or we know that there are 60 minutes for every 1 hour. Okay, so these are all equivalent statements. We're looking at two units and how they equal one another. All right, and so even though the units are maybe different, in an equivalent statement, each side of the equal sign describes the same physical quantity. So now to change an equivalent statement, all right, so change equivalent statement to, can't even spell statement, to change an equivalent statement to a conversion factor, all right, so what you have to do really, and it's pretty simple, you will simply change the statement into fractions, all right, and usually there's only two different fractions that you can make. So like, for example, so we have this first one here. We have 1 meters equals 100 centimeters. How can we change this to a fraction? We could say that for 1 meters over 100 centimeters. So that's one conversion factor. Or we could just flip it, where we have 100 centimeters to 1 meter. Okay. Here's another example. With 12 inches in 1 foot, you could say 1 foot at the top. Over 12 inches, or we could say 12 inches at the top over 1 foot. So you're just making these into fractions, and for each of them you can only really make two different fractions or two different conversion factors. This last example, we have 60 minutes on the top over 1 hour, or 1 hour over 60 minutes. So these are all your conversion factors, which are derived from your equivalent statement. Okay, so how do you know which conversion factor to use in a unit conversion problem? Well, the answer really relies on the units. If you use the units, you could easily figure out which conversion factor will be best to answer your problem. Okay, so like, for example, let's say, and I'm going to use this first set right here. So let's just say that you've had something that you measured something that was, all right, you had 10 meters, all right, of a particular substance, of a distance of a particular substance, or the length, whatever, and you want to know what's that in centimeters. Okay, so you're starting at 10 meters, you're going to centimeters. So now when we're looking at these two conversion factors, before we get to the conversion factors, we realize the relationship between meters and centimeters is this. For every 1 meter, there's 100 centimeters. You change those to your conversion factors. So there's two different conversion factors that we could possibly use. one of them, we have to use one of them. Either it's 1 meter over 100 centimeters or 100 centimeters over 1 meter. So which one to use? All right. So we're going from 10 meters to centimeters. So when I set this up, I have 10 meters. I'm going to multiply by a conversion factor. Which conversion factor to use? Well, let's use the units. The unit's going to be our guides. If we think of units as a particular number or something that can be crossed out, like we typically cross things out in, especially when we're using fractions, then this kind of makes sense. So like, for example, if meters is here, so this is kind of like your numerator. So 10 meters is kind of on the top of numerator, right? To cross out my meters, I need it in the denominator, okay? And I'm going to centimeters. This right here is going to cross out my meters because they're on two different sides of your fraction line, right? Or your division line. And then I'm trying to convert to centimeters. And so now when you look at this setup here, then you was like, okay, this setup looks like what? Like when we see how the units are laid out, all right, which conversion does that look like? Well, it looks like this, okay? And so then basically you're just going to kind of rewrite this where you have 100 centimeters on the top. Sorry, I used the wrong thing. 100 centimeters at the top, 1 meter, 1 meter at the bottom. And this is my conversion factor. Okay, and so all I have to do is 10 times 100, and that's going to get me my answer in centimeters. Okay, let's look at another example. All right, so let's just say that we're going to look at the second one. Let's just say I have, something is 36 inches. I'm keeping the number simple, just for simplicity's sake. All right, and we're trying to convert this to feet. Okay. Now, we know that there are 12 inches in every foot. That's our equivalent statement, okay? We're going to change the equivalent statements to conversion factors by making them fractions. So 1 foot per every 12 inches or 12 inches over 1 foot, all right? And now we're going to let the units help us decide which conversion factor we're going to use. So we start out with 36 inches, all right? And we're going to multiply this by conversion factor. Well, let's use the units to kind of guide us and help us out. You have inches up here. I'm going to put inches down here, all right? That way it will cross these inches out because I have one in the numerator and the other one in the denominator. And then I'm going to feet. That's what I'm trying to get to, all right? And so when we're looking at the setup of this units here, all right? Hopefully you notice it looks just like this one here, the one on the left side, all right? So I'm going to rewrite this. So I have 1 foot over 12 inches, and now I'm just going to do the math, 36. So basically what you're going to do is 36 times 1 divided by 12. You all guys are geniuses, and so you know that this is roughly 3 feet. Oh, actually, let's give correct number sig figs. So it's not just 3 feet. How many sig figs do we start off here? Remember, this is 2 significant figures, right? Here is a definition, so it has unlimited amount of significant figures. So it's not based off of the conversion. It's going to be based off the numbers that we start with. So we have 2 sig figs here, and so our answer should have 2 sig figs as well. So I'm going to write 3.0 feet, and that will be my answer. Okay. And so just one more example. Let's just say, I guess we could go a little bit harder. Let's just say that the amount of time that it took you to go from city A to city B is 5.63 hours. And you're just really wondering, how many minutes was this, right? Well, we know that the equivalence statement is that for every 60 minutes, there's 1 hour, okay? And now we're going to change the equivalence statement to conversion factors. We got 2 conversion factors, all right, 60 minutes over 1 hour or 1 hour over 60 minutes. Now let's kind of figure out which of these conversion factors are we going to use in this problem. Well, we're going to start with 5.63 hours, okay? Here's where our conversion factors is going to, we're going to write the conversion factors, all right? Since we have hours up here, I'm going to rewrite hours down here, all right? So that way I could cross it out, okay? And I'm trying to figure out how many minutes, so I'm going to write my minutes on top. So when we're looking at this overall structure, this conversion factors, okay, what does it look like? Well, hopefully you notice that it looks like this conversion factor here, okay? And that's what I'm going to write. So I have 60 minutes divided by 1 hour, okay? And then you'll plug this into the calculator. When you do that, you notice that you get the answer from your calculator to be, I'll write it out to the side, 337.8 minutes. Cool. Now, we still got to consider significant figures, all right? And so, as I said earlier, when we look at this number, we say, okay, this is 3 significant figures, all non-zero numbers, all non-zero digits. This conversion factor, as I said before, has unlimited amount of significant figures because all conversion factors are considered to be definitions. Okay, so we cannot base the number sig figs off of a conversion. All right, so our answer should have 3 sig figs. When we're looking at what the calculator gave us, the calculator gave us 4 sig figs, so that means the one to the very right, we're going to kind of cancel out. But the one on the very right is going to also determine if we have to round the number or not. This is greater than 5, so we're going to round our 7. And so our answer in this case will be 338 minutes. All right, and that's our answer in this particular situation.